Hello, everyone. Hello, Brian.
Hey,
Hey, happy to have you here on the other channel on Talk Python.
yeah,
You've been here many times, but I don't know. Have you been on the StreamYard live stream
I,
variation of
I
it?
don't think I've been on a live episode yet. No, so
Yes, but if there's anyone who I've done a lot of StreamYard live stream stuff with, it's you.
yeah, every
Python Bytes.
week.
Exactly. So, for those of you who are all here, thanks for being here. Comments and stuff in the live chat. We'll try to make it part of the show. I'll send them over to Brian. And with that, let's kick it off, huh?
Yeah,
Brian, welcome back to Talk Python to me.
well, thank you. It's good to be back.
It's really good to have you back. I don't know if you've noticed, but over on Talk Python, I put up a guests page. And who is out of the 440 guests we've had, you are the most common guest. And you are now pulling further away from Brett Cannon and Anthony Shaw, who are hot on your tails there. So I'm sure people know you and are familiar with your work. But for those who don't, quick introduction.
Well, I probably give people probably know me from Python Bytes actually. And also I have a test podcast called Test and Code that's kind of on pause right now, but it'll start up again in a month or so. And then, but okay, so I am a software developer, mostly embedded, as so day job software embedded to C++ stuff. Work with RF test equipment, but I got involved with Python and PyTest around the testing part of that, the system level testing, and then I started writing about PyTest and about test stuff, and then I started podcasting about it, and then I started writing books about it and all that sort of stuff. So all of this came from me, and my love for Python and PyTest came from my embedded world. So that's
Yeah,
me.
I suspect a lot of people don't really think about it that often, but Python is great for testing things that is not just other Python code.
Yeah, I mean, there's a lot of people that, like, for instance, use it even to test websites that are not written in Python, just because, or not written, yeah, not written in Python, or not written. Like, you can test Go, you can really test any website. So if
Yeah,
you can get access to it from Python, you can test it with PyTest. So yeah.
right on. And we're going to see a whole bunch of cool tips and tricks and ideas about how to do that with PyTest and to do it better. Because as you
Yeah.
said, you've been using it in your day job. You've also been using it in a semi non-standard way, right? Like testing both C++ code and actual hardware, which is pretty awesome. And you've got a lot of exposure through your book and other things. So it's going to be really fun.
I also wanted to say that early on, so getting started with podcasting is nerve wracking. It's a stressful thing. And way back when I was just starting out on testing code, um, you were very encouraging and wanted me to be successful and keep going. And that meant a lot. So thank you.
No, thank you for saying that here on the show. I really appreciate it. And 5, 6 years later, ever long it's been, you're still going for sure. I mean, tomorrow we're doing another show on Python Bytes.
Yeah, it's been great.
Yeah, thanks. All right, and I guess I did want to give a shout out to Python Bytes. I don't speak about it that often on Talk Python. Every now and then I do, but usually I'm speaking to guests who maybe are not familiar with it. But that's the show you and I do, and so I really want to encourage people who like this show to also check that one out. Tell people what Python Bytes is real quick, Brian, if they don't know.
Well, it's Python headlines and news and headlines delivered directly to your earbuds.
That's right.
But the gist of it is we both pick a couple topics per week, and we don't even really talk about it ahead of time. We just pick a couple of Python related topics that we want to talk about. And could be like a new library, could be an old library, or a tool, or a blog post, or something happening in the news, and then we just talk about it for a few minutes. And then the other one asks questions, and when we have guests on, they come in too. One of the things I really like about it is it's always fresh, and then also that that people have said, if a topic I'm not interested in, I just wait a few minutes, and there'll be something else I can listen to. So that's cool.
Exactly. That's really fantastic that it's always something new. And it's great for us. We are always on top of things, always learning, but I think it's really cool way to stay on top of what's happening in the Python space.
Yeah, and for me personally, it's an excuse to stay on top of things in the Python space. So, yeah,
Not just an excuse, a requirement. You got to be on the microphone in 2 hours. We're going to figure it out. Yeah,
Yep.
awesome. All right. Now, also, I do want to point out that over on Talk Python Training, you did a really great course calling Getting Started with PyTest, and people can check that out. As well as for a couple years now, you've iterated on your book, Python Testing with PyTest, onto the 2nd edition. So those are 2 really good resources. I feel like you're probably going to be drawing from for some of these tips, right?
Yeah, definitely. And so the first book launched into having the ability to be able to teach more people. So I was able to teach other corporate people and individuals, and then I took that learning from like how to teach people how to use PyTest, and used that to influence the 2nd edition, complete rewrite. And then took all of that and leveraged it into the short it's like 3.5 hours. It's really short for the Getting Started with PyTest course. And I really kind of like what we've done with that. You helped out a lot with that course as well. So
Yeah. I look back on my college career. I don't know how you feel about this, Brian, but I look back and think, a lot of times there's sort of the meme, like that could have been an email for a meeting these days. Like I kind of feel that way about college. Like a lot of stuff I did in college could have been 4 hours. It could have been a 4-hour course that I spent a week on, but no, I spent a whole semester and
yeah,
6
exactly.
hours.
Yeah.
You feel the same way looking back?
I do. And yeah, there's a lot of stuff that I'm like, wow, that could have been like even a half an hour course. It just yeah. But
Yeah, exactly. So I feel like you've condensed it down really well here. So people can check out the course and they can check out the book as well. So a lot of kind comments in the audience as well. I'm seeing for your book. So thank you, folks.
nice.
Yeah. Well, I guess I envisioned us to kind of talk about this as a podcast, but you leveled this up a little bit here. You took this and put it together as an article so people will be able to come back to it, right? This whole idea of these tips and tricks.
Well, I wanted yes, because we were bouncing around ideas for what to do, and I and you mentioned like maybe some tips and tricks from the course and pull them together as a episode. And I'm like, you know what? I haven't ever done that. So I pulled together a blog post called PyTest Tips and Tricks. And it is a blog post, but it's at pythontest.com. But I do want to keep it going. So I'll probably some of these topics I'll probably bring into create full articles out of them, and some of them are just as good as is things. So
it's a living blog post.
Yes. And you started it. So there was a bunch of you started a document that had some of the stuff that you pulled out. I don't know where you got all these stuff that you started from.
I went through your course. I paid attention.
Nice. So cool.
No, it's good. There's a lot of, for a like a getting started sort of story, there's a lot of really good tips that I think are useful for a lot of folks. All right. Well, let's jump in. You've broken into these different areas, and I mean, maybe I'll kick it over to your screen for you to
okay
follow along. Yeah. But yeah, let's kick it off.
Yeah. So I want to start out really with one of the things that it's so simple to start PyTest. So and I think a lot of people get into it. So it's really simple and easy to use. To start with, you can just write a file called test_something, and then stick a function in it called test_something, and that PyTest will run that. And if you can access whatever you can access with that, you can get started. And I think it's a really cool feature of PyTest that you can get started that easily. But also, I don't think very many people learn too much more. They'll look up. They'll somebody will mention fixtures, so they'll look that up, or parameterization. They'll look that up.
Probably they'll say, "How do you catch an exception? This is supposed to be an exception. Like, how do I do that?" And maybe.
Yeah, and
I gotta say that part. I gotta say that part. That aspect of it confused me a little bit when I first did PyTest. I'm like, well, how do I make it do PyTest things? It's just a file, and then I can do Python a search, but how do I do like tell PyTest it's supposed to be greater than 7 or not.
Yeah.
There's a lot of sort of implicit magic behind the scenes as part of that, right?
Yeah, there is. And I like, for instance, just using normal asserts, because with like unit tests, you have to do a whole bunch of extra assert methods and helper methods and stuff, and you have to derive with unit. And it's often people coming from unit test or some other X unit style that are confused at the simplicity, because people are used to deriving from a test class or something. And then I actually saw the reverse of it. I saw people that were not used to X unit style. They just wanted to write some test code. And this whole notion on the unit test of deriving from a class, I saw a whole bunch of people that I tried to teach unit tests to say, oh, well, I'm going to have to go and learn about like object-oriented programming.
Right.
And I'm like, oh, you don't. It's just the structure. That's all. You don't need to know how to use it. But so that's one of the nice things. So I have on the screen just a simple test. I've also had a lot of people ask me, well, can you give me a template for what a default template for a unit test or a test? And I'm like, well, it's just test underscore. That's your template. I mean, there's nothing to put in it. I've said, okay, for my template, you at the top of your test, you write getting ready, like a comment that's like getting ready for or setup or something. And then you set up all the stuff. And then you do an action in the middle. And then at the end, you assert what if the action worked. And there you go. There's a template.
There's two traditional styles of structuring this. The early testing days were the 3 A's, the arrange, act, and assert, which is kind of a little bit like what you got here. And then there's the given, when, then, which I feel like a little more BDD world.
Yeah. So
maybe.
I learned. So I learned given, when, then when some of the early writings around BDD, and I just liked it. I liked the notion of like, oh, given some state, if I do that, when I do something, then something happens and I can test that something. Now, there wasn't any structure around it. There wasn't any code. So now BDD has these Gherkin syntaxes and stuff. And for people that works for, awesome. It just doesn't work for me. But the notion of behavior-driven development, not the syntax, but the notion of think about the different behaviors of the system and test for it, that I love. So, but the given, when, then, and arrange, act, assert essentially the same thing. But anyway,
do you feel like the nomenclature of BDD maybe hampered its adoption, like talking about like cucumber and gherkin, and just you go to your boss and say, we're working on the gherkin fathering, and you need to do real work?
I think I don't want to be a pessimist, but I really think what happened, my guess is that it's such a simple concept that there wasn't hardly anything to charge people for as a consultant. So
or to give speeches and conference talks about, or whatever, right?
Yeah, but if you add like this extra gherkin layer on top of it, now you have something you can train people about.
There you go. Way to productize it.
Maybe. But so I think it's all good. Just don't pay for it.
All right, before we move on from this topic, I think the arrange, act, assert, or the given, when, then is a really nice way to think about it. But I think there's still a large set of folks who struggle to know what scale should this be. Should I do 15 asserts? I've done all the work to get them ready. Should I do 1 assert? If I do 2, am I failing? I was supposed to do 1. Now 2 is the wrong. 2 is too many. How do you feel about what goes under those 3 comment sections?
I'm glad you brought that up. So the one action should be like 1 function call or 1 method call or something, if you can get away with that. And the getting ready stuff, it could be a lot, like especially for the first time. So one comment, dollar-driven development. That's funny. we're going to get to fixtures later, but I think it's okay if it's a whole bunch of setup. So it could be like a ton of setup that you have. Like most of your code of your function might be getting ready to test something. And especially for the first iteration of the test, that's fine, I think. And that's where it's good to have comments or a comment, even like a very visible comment block with a bunch of lines and stuff like that to separate the different parts. As far as the asserts, there's a lot of people that think like you have to do just one assert and you're failing as a developer if you do more than one assert. And I think that's not true. There's problems with doing more than one assert, but if you're am I doing an action, and if there's like several things I have to test about whether or not the action is right, like in my world with the RF systems, if I'm setting up a signal and I'm measuring a signal. Now, what is the if I to test that I got the right signal at the end, I might be testing the power level and the burst width and the burst length, and I might be testing a whole bunch of stuff around it. And yes, I could separate those all into different tests, but if it's really conceptually the same thing, I think it's fine to have multiple asserts. But if you really
Right.
don't want to, there's ways to get around not doing multiple asserts.
Just use semicolons, a lot of ands.
Well, you can you can stick like let's for booleans, for instance, if you had like 6 booleans that you were testing, you could stick those in a list and compare the list to a list of expected booleans.
Sure. Or you could, I mean, you're kind of like saying like, how can we draw this out? But there are legitimate ways. Like you could use the any iterator type of thing, or you could use the all, say all of these things have to pass this, or if any of them fail, then that's a certain not any, something like that, right?
Yeah. And one of the problems of not doing that is that your test stops at the first failure. So and if that's a problem, and sometimes it is, you really do want to see the entire state of all of the because it might help you debug it. Like I returned the return code of a web page was like 400 and I expected it to be 200. But you might want to know,
see the message. You would be so much better.
Yeah, if you could see more, or if you're testing the title and that's wrong, but you know what I mean. If you can see more than one bit of information, it helps. So,
yep.
Yeah.
Now, I think that's also to be differentiated, as we'll get to later, in some other tips from. Well, there's different cases. Like, what if I pass it a 0 and I pass it a 10 or something above 100? All these different inputs, and then I want to test every. That's a different story.
Oh yeah.
Right. So we'll get to that. All right. What's next?
Well, I wanted to, since we're talking about structuring a test function, I thought it'd be great to just remind people that you have a whole suite. So it's good to think about how you're structuring your whole test suite. And by test suite, I just mean a directory of stuff that has tests in it. PyTest allows you to have your tests interspersed with your code, but I haven't seen that for a long time. A lot of people just have really a tests directory, and that's what I'm used to. Anyway, or a couple directories. Like I often have an examples directory that I want to make sure all those examples still work, like for PyTest plugins, and I also want to have the tests themselves pass. But anyway, structuring the tests directory is good. There's a bunch of ways to do it. I like to separate based on like functionality. So different like behaviors of a system and conceptual separations of the system into different functionality bits and separate those into directories. You can also structure it based on like actual software subsystems in your software. And then some people do like the same code structure. So they have like the exact same directory structure in their tests as they do in their source code. But I think just making sure you think about it and don't just think there's one answer. It's really how you want to run the tests. And it helps me if I'm working on a behavior or if you're normally working on a subsystem at that level, then subsystem makes sense to test. So that you can just like I'm working on my particular bit of code, and so I'm running those tests related to that. It's kind of how you're running the tests is how you're going to. Anyway, it also
it depends how you think about it, right? And how it's organized in your brain.
Also, there's reporting considerations. So if you have to, if you're reporting to outside people that your like tests are passing in different chunks, um, the reporting might be easier if you structure it one way versus another. So anyway,
So let's see here. The structured like your software or subsystems, that's straightforward to me. Like I've got a data access layer. So here's my tests that test the data access layer, presumably mocking out the database, but maybe not. When you think about having it in subdirectories, you would just have maybe subdirectories of those. And I guess another you could think about is like really, really slow integration style tests versus more units, for lack of a better word, tests. Right? Like these are the ones, excuse me, these are ones I can run now. These are the ones that take an hour. Let me run the ones that could take now. Like, how do you, what's your style?
Well, I do actually. So I do. I'm not really that great at like throwing in unit tests because I don't really see much value in unit tests. I know that I have to have behavior and like tests that test the end user functionality.
Yeah.
At the point where that is testing all of my code, then I don't feel the need to add unit tests. But there are times where they are needed, which is great. I do think it's great to separate those. And like, so the top hierarchy of separating like behavior versus unit tests into one big chunk.
Yeah.
The main reason why I like that is because I really want my behavior tests to be, if I'm going to do coverage, I really want to know if my behavior tests are covering all of my code. It doesn't really help me much to know that my unit tests are covering all my code because that could lead to dumb tests that really,
Yeah.
I mean, I might be tempted to, there might be a corner case of my code that I can write a unit test for, but I can't reach otherwise. So I think it's better just to delete the code.
Yeah.
But anyway,
honestly, we might get our PyTest certifications taken away, or our Agile certifications taken away. I don't really have one, but I agree with you completely that some of these larger scale tests that kind of, test larger bits of code, they might not be 100% on catching all the little things you could test, but usually if I break something, many of those break. It's usually enough to catch the mistakes.
Yeah.
And they're easier to write 20 big scale tests than 1,000 small ones.
I've also never had a customer reported issue that could be reproduced as a unit test. Just saying.
Yeah. Avaro out there says PyTest docs talks about a slow mark just for that use case, which we will get to marks as well, but that's definitely a good recommendation. So maybe not actually using the directory structure for slow, but using marks. So coming back to that, but let's carry on.
Yeah.
That was structuring a test suite, which is excellent.
Okay, so I don't know why how the transition is here, but I picked fixtures as the next thing. I think one of the first things people need to get used to with PyTest is fixtures, because it is the big brain shift from any other test framework. And they're pretty cool. So it's really just a function that's split in half. We've got a setup half and a teardown half, and they're separated by a yield keyword that separates the setup and teardown. And PyTest will call that before your test and then finish it up afterwards. That's about it. Really.
Well, I think part of the transition is you talked about the 3 A's, the arrange, act, and assert. Like the arrange part, if that's going to get reused, well, fixtures are pretty well built for that. And you could have more than one fixture in a test, right? You could say this part arranges the database and this part arranges, I don't know, some set state of the app that you're going to, make them collide and see what happens.
Yeah, or connections to resources and all sorts of stuff. Yeah, or data. You can have fixtures that generate data for you, and there's many that do that. But one of the things, I guess I should have this as one of the tips. In writing a test, I recommend putting like especially the first test for something you write down, just write it in the test. Now, when you go to write the second one, that's a good time to go, how much of this setup is shared? And if all of the setup is shared mostly, then you can maybe it makes sense to throw that in one or more fixture. But I have seen people just copy it. Just like take it and put it into a fixture, and I call the fixture setup. Um, that's you can do that. It's a little dangerous though, because what are you setting up? I'd rather have it be maybe multiple different ones, like setup database, or configure the network or something like that. Have it be descriptive. You've got a word there. Setup just doesn't say much, so say something, I guess. Yeah.
Well, that goes back to the whole part of testing that is documentation of how the system works.
Yeah.
And part of that should be really good names for your tests. You have the advantage that no one is ever going to try to use your test code as an API. So it can be a ridiculous name. It's like 15, 20, 30 characters, because no one's going to be upset. The test runner doesn't care that the name is long.
Yeah. But the person that is going to look at it is either you or somebody else when something's broken and they're stressed out. So when they're trying to get done with their day and the test doesn't work and they're looking at the code going, what are we doing here? So yeah, being verbose there is fine. In back to the RF world, like let's say I'm setting up both a transmitter and a receiver before a test. I might be tempted to throw both of those in one fixture, but I have before, but I almost always end up splitting those up and have like setup transmitter, setup receiver, setup measurement system, have those separate, because they're more reusable as parts later and stuff.
Right. So maybe you need a receiver, not a transmitter, for some particular reason somewhere. Yeah.
Another thing is, it's okay to not reuse fixtures, and they can be in the same file. So you can, if you just have like this huge setup and a little tiny like do something section, it's really nice to just throw that into a fixture. There's lots of reasons to throw that in the fixture. One of the great reasons is you can put asserts in the fixture. And you don't want to sprinkle asserts through your test, because then your test fails and you're like, was the setup failure or not? But PyTest is awesome that if the assert happens in the fixture, it doesn't report the test as a failure, it reports it as an error. So fixture asserts are errors, and then so you can separate when you're seeing all of your entire system's failing, but there's really only one failure and all the rest of them are errors. It might be that like you're just not connecting to the database or something like that. So
yeah, interesting. Out in the audience, Jeff says, one thing I missed on my first trials of PyTest is the differentiation between error and fail, which sounds a lot like what you're talking about there.
Oh yeah. And so, and his comment around unit test, because unit test is a little different. Unit test makes I think it's the assertion error versus other exceptions. So I think that's the case in unit test, that if it's like an assertion error, it's a failure, and if it's any other exception, it's an error. PyTest completely different. Any exception, assertion or otherwise, that happens within the test itself is a failure, and any exception that happens that's uncaught in a setup or in a fixture, that's an error. So
oh, that's cool. I didn't realize that differentiation. Yeah. Also, a question from Thomas: if you're just having the fixture there to provide data, is it necessary to use yield instead of just returning the value, the data?
I usually just return the value. I only use yield if I have some work to do for a teardown.
Yeah.
So
I think also it's just kind of interesting, just that yield, and what a clever use of generators, right?
Yeah. It's very clever and also very nice, because in you can have variables there that are needed for the cleanup, but you don't need to return to anybody or something, or save them in a global variable. They can just be in the function, and that's it. So like, database, connect to the database, keep a handle to the database so that you can close it at the end. It's
Right.
very,
Or
very
start a
quick.
transaction and roll it back so it's whatever you did to it's unaffected. Yeah.
Oh yeah.
Yeah. Cool. All right.
So-
What's next? That was fixtures.
Well, so
Or
if you've
unless you
been
got
using,
more fixture.
yeah, more just you made this comment, and I'm like, I've been doing PyTest so long that I forgot about it. Old time PyTest stuff had to add finalizer before we kind of settled on the yield system. I would say avoid add finalizer. It's just going to confuse people. So don't do that.
Yep.
Also, you can nest them. So leveraging using scopes. So you can have like connect to a database by a session scope, and then cleaning up the database as a function scope thing, so that save time. So, and then conf test files if you want to share them between tests, you can throw the fixture in a conf test file. So,
yeah, it's not necessarily obvious that if I put a fixture and then have a bunch of tests below in the same file, it's obvious I can just use it. But then if I go to another one, I could be like, well, what about that? Those over there, I want to share them across these files. So this conf test, this is what that's about, right?
Yeah, and a lot of people think you can, or their first attempt is to throw them all into a different module and import the module. You can't do that. Don't do that. And you never want to import the conf test file. It's not an importable thing. It's just PyTest deals with it. So
yeah, indeed.
And okay, so on fixtures, there's a bunch of built-in ones that are super cool, and in the long time, like if you've used PyTest for a while, we used to have, and we still do, a couple of fixtures called Tempter and Tempter Factory, but there's newer ones. They've been in for a while, but some people don't know about them, called TempPath and TempPath Factory, and they use pathlib path objects, which are awesome. So use that if you can.
It took me a while to love the path class, but I love it now. It's really nice.
Yeah. And also the old one was like just this py.path.local object, which was very undocumented. So I don't recommend it. The temp files within PyTest, so it's great. If you're like if you're generating a file or whatever, or you want to save some CSV stuff, it's good. It sticks around too, which is kind of cool. It sticks around for a little while, so you can interrogate your temp files like after a test run is done. You can look at the and if you're trying to debug the failures, those temp files will still be there. They're not cleaned up directly after. They're cleaned up in a future test run.
Oh, that's interesting.
Yeah.
They're like a n-1 or n+1 lifespan or something.
Yeah. There's a bunch of built-in fixtures. There's only a handful I use very much. I use TempPath and TempPath. So there's TempPath and TempPath Factory. The factory versions are used because TempPath like is a per test run, like per like every function it gets generated. You can't use it if you've got a session scope fixture. So the factory ones are session scoped. So if you want to use it, anything larger than function scope, use the factory to generate a temp directory. So use that.
Cool. Yeah, got it.
Capsys, a lot of if you want to look at if you're checking your output, Capsys is good for checking the output of something, the standard out or standard error.
Because PyTest captures and eats some of it, right?
Yeah, by default, PyTest will always capture the errors and output, and only print it out for failing tests. It'll say, oh, here's the output for the test and it failed. So that's helpful, but it's normally gone. And if you want to, you can use Capsys also just to disable that for temporary bits of your code. If you want to throw a log out there all the time or something, you can use that. So, but I usually use it just to look at the output. So especially with PyTest plugins, I want to see if I've modified the output. I want to see the output, so I can use that to grab that. So, there's Monkey Patch as well. You can use this for all sorts of stuff, but I usually, if I'm doing fancy things, I usually like actually use just mock,
right.
Unit test mock. But for things like changing your environment, it's great. So you can change environmental variables or quick patches. It works great. The neat things about these, other than just doing it yourself, is that it cleans up afterwards. So if you patch like a system with like a dummy bit of system or something, after your test is done, it goes back to what it was before. So that's pretty cool.
Yeah, because otherwise you can end up with a problem of the order of operations is left in this half-patched state where something else depends upon it, right?
Yep. Yeah. PyTest config is used for grabbing command line flags a lot. That's mostly what I use it for. And then the only thing I usually use request for anymore is if from a fixture I want to know what the test name was. You can use request node name to grab the test name. I don't think I use it for anything else anymore, except for parameters to grab the parameter values. But yeah, anyway.
Nice. All right. I pointed out Mark, or
audience.
They pointed out Mark, and here we are. Markers.
So pytest.mark. Whatever. You can use custom markers. Markers are great, but don't. When I learned about markers, I put them everywhere, and then I'm like, oh, that's just sort of. It ends up being messy. So, it can be. But it's a great way. So it's like just adding a tag to a test or a test case or something to say that you can use it to run it. So you can say, I want to run all the tests that are marked like user interface. You can run all the UI tests if you didn't separate them by directory. Or like somebody said, you can mark all the slow ones and only run the slow ones or avoid running the slow ones.
So you can do a not in your execution. You can say run the things not marked slow.
Yeah. You just say, well, it's -m. I should throw that in there. -m, like not slow.
Got it.
And just, but it's 2 words. So you have to put it in quotes, like -m quote, not slow. It'll work. And you can mark files with a magic keyword called pytest mark with no spaces. If you throw that in your file, PyTest will see it. So there's a bunch of built-in ones, marks. The ones that I think are probably most common are skip, skipif, and xfail. And I guess
you expect it to fail. Like, I know it's failing, but that's okay.
Yeah. So a lot of people might think, why would you ever expect a test to fail? You should just fix it.
No, I know. No. It's Friday, 3:00. You got plans, but you got to fix the build.
Yeah.
No, seriously though, why would you use this?
Well, believe it or not, some people are not responsible for all the code.
Yeah.
There's teams. So one great reason to use xfail is to submit a defect. And then you say, I know this test is failing because of this issue. You've submitted a defect, and then you throw the defect number in the xfail reason string, and move on. Now your build is still working, and there's but just be careful. I mean, xfail is this big thing. So I think as whether or not you use xfail, it needs to be like your entire software team needs to understand it and agree on the process, because there needs to be a process around how to utilize xfail, because it can just sort of hide failures, and you don't want that. That's one of the reasons why I really like xfail strict, that it makes it so that so that like if they pass, if you mark it as fail and it passes, it'll just pass. But we want it to, well, it X passes. It expected, which means I expected it to fail, but it passed. But I like to just have it be a failure, so that somebody can look at it and go, oh, yeah, we need to take these out of the test and close the defect or something like that. The other thing that people should be aware of I don't think a lot of people know is the --run xfail flag. And this is especially useful, like to just say, okay, screw it, ignore all the xfails and just run as if I haven't marked them xfail. And so that
maybe you're fixed and you don't know. Maybe they didn't take away the xfail.
Yeah, but they might, or you just want to make you like in a CI system, for instance, like if you're running, most CI systems don't understand all of the different variations of like outputs from PyTest. Like they don't understand X passes, X fails, and skips, and all that sort of stuff. So and a lot of times then X fails and X passes just show up as just passes and fails. And so you don't want just to pass everything. So run X fail if you just want to say I want to just run everything, and if there's any failure, I want to see it. So that's good. But anyway, just be careful with X fails. I've seen it confused people. So
yeah, it makes sense. What's the story with skip and skip if?
I guess it's the same. I mean, like, why are you skipping something? I guess you have to be careful. So, but skip is just skip this test. It doesn't run it at all. And skip if, you can put logic in there to say like, well, if it's on, and so it's a great example of skip if is if you've got operating specific, like maybe if you have operating specific chunks of tests or chunks of code or something.
Skip if platform equals Darwin to skip the Mac OS ones, because
something like
you got no chance.
Yeah, or if we're talking coverage and unit test again, for example, maybe you've got functionality that depends on Python 3.12, but you also want to test on Python 3.7, and so some code is only going to run. You're running different code for the same functionality on two Pythons. You might want to like have two tests, and one of them gets run on Python 3.11 and one of them or 12, and one of them gets run on all of the other versions, and you can use skip if to gate those. So
interesting.
Yeah.
Okay. Yeah, that's really cool. Hey, before we move on, we've got an interesting question or idea out here from Jeff in the audience, who also is a hardware tester. Said, I'd like to distribute fixtures in some way to people as a Python package.
Like that's a great idea.
Yeah. What do you think about that?
I think that's a plugin. So let's jump to plugins then. Did I have a plugin section? I didn't. Maybe I don't. Let's go to the top.
Well, notes for a new section.
Yeah, plugins.
It's a living blog post.
Yeah. Yes, I think it's important to be able to package them as plugins, and we don't cover plugins are kind of a little advanced thing. I don't think we cover using plugins in the course, but in 3.5 hours, I don't cover how to write a plugin.
Yeah.
I don't think. But there's a ton of plugins on you've got the PyTest plugin list on PyTest. But also you can search for, they're usually PyTest dash something. So you can search for that on PyPI as well and see a bunch of plugins.
Yep. You even have some out there for yourself, right?
Yeah. Quite a few
lot.
actually.
I mean, I'm scrolling. I'm still in the dash A. That's a lot of content there. So I guess one tip is people should just go scroll through that list and go look at all these things they could just fixture into their.
Yeah.
Right.
Or one option is to go to PyCascades this year and watch my talk because I'm giving a talk at PyCascades about packaging PyTest fixtures.
That's cool. That's cool.
So
when is that?
That is March.
It's coming up soon, right?
Something. It's in March. I should look it up. So
nice.
Real time.
Yeah, I'm pretty sure those videos will be online afterwards if people are not at the conference in Vancouver. Although Vancouver is lovely.
Yeah. Oh, yeah. They'll be online, and I'm also going to publish the slides. I just got the slides done, so it's March 18th through the 20th, and I think mine's on the 19th. So
cool. All right. Nice.
Yeah. So anyway,
all right. Which section want to do next? We got a little bit more time.
Well, so we talked about markers and fixtures. Parameterization is definitely something I think people should learn about. And because especially if you I've seen a lot of test writing utilize copy, paste, modify. And I mean, it should be a red flag for all software engineers, but for some reason it happens a lot in test code of copy, paste, modify. You got a bunch of tests that are kind of the same, and you just take one that's similar to what you need and change it. And you end up with a lot of test code that way. And one way to fix it is to use parameterization. So
Yeah. Anytime you've got a lot of, you're like, this is happening over and over again in my code, it should be, it's a code smell, right? You should know there's some refactoring. Or alternatively, Brian, you could get this fancy new Stack Overflow keyboard.
that's awesome. Which has
It's
3
the
keys.
Yes, exactly. Go ahead.
3 keys. One of them goes to Stack Overflow. One of them is copy, and one of them is C and V, so copy and paste. So that's awesome.
Yeah, the power of copy and paste, indeed.
I assume you have to have a mouse connected to select the stuff to.
Yeah,
but,
probably.
But it really does happen a lot of people like copy another test, change what they need, and then run it. Now there's a bunch of problems with that. One is people sometimes forget to change the test name.
Oh yeah.
And then the test. So the test, if you can have 2 functions with the same name in Python, and it just like runs the second one. So that's one of the reasons why I'd like to also run coverage. If I'm going to run coverage, I want coverage on my tests too. And to make sure I have 100% test code coverage.
So what happens when you run into that scenario on PyTest? Does it just pretend the first one wasn't there and it got overwritten before it got to it?
Yeah. Just like, any other in any other Python module, if you write the function name again, and even if you have different parameters,
it's so easy to do. It doesn't care.
It doesn't. Python doesn't care.
Yeah. So different web frameworks will handle this differently. Flask will throw an error and say, you've tried to use this function before. No, when you do an app.get or something on it with the decorator.
Yeah.
For example, Pyramid, which I've used a lot, doesn't. It just erases it. So you just end up getting like 404s for whatever was there before. You're like, well, it was just working. Where did it go? I didn't even touch that part of the program and it's just gone. It's like, I don't understand, and I can only see that it's even less obvious with PyTest. Like that how much would you notice when it goes ... that like it didn't increment a dot when you added a test? You might not.
No. Well, yeah. It's dangerous. But okay, so you get around that. It's the other thing of just like thinking about it. So if I write a test to begin with and I think, well, I've set up like, okay, so if I go to this web, really I'm just making like a web page thing. I just want to make sure this page gets a 200. Is it 200 right for the good?
Yeah. Yep.
And I want to make sure that gets 200 and the title's right or something like that. Now I might have just a list. I mean, that would be an easy test just to make sure all of my pages, normal pages are alive, is to just go through and test all those. Now I could either just have a list of all the different pages I want to go to and just ping through those. And that could be a loop within my test. But that's a loop within a test at the assert at the bottom that doesn't count as the assert at the bottom. It's because you're asserting through the whole thing. May as well just make that a parameterization and go through all the different pages you want to hit. And for each of those pages, make sure it's a 200. And then you could also like have the title in the parameterization to say, this is the page, this is the title. Now for each of those, go through and test it. And those are different tests. And it's going to be almost as easy to write one test as it is to write now a bunch of test cases with parameterization. But PyTest has a whole bunch of cool parameterization tricks. You can do function parameterization. You can parameterize a fixture. You can even use PyTest generate tests to do some fancy parameterization. But for the most part, if you're new to it, stick with function parameterization. It's powerful, and hopefully that's all you need. So
yeah, if you've got all these different cases to test, I mean, the value of testing often is to give it the good value and see the good value comes out.
Yeah,
that's true. But it's also really valuable to give it all those weird edge cases where you want to check boundaries. Like if I give it one less than it should have, it should tell me that's an error instead of crash. If I give it something, like just all the little weird situations. So testing all the failing cases and having those scenarios as a parameterized story is nice.
And one of the comments, which I have seen before and I kind of agree with, is that my code is dry and my tests are wet. What that means, and what that means is because dry testing, people can go overboard with dry to the point where you can't understand what's going on. And so especially for tests, you want tests to tell a story of, I'm doing this thing and I did this other action, and then now I can tell that it works because of this. And if you break that story up too much, then you don't know what the story is. So if you hide all of your asserts in a helper function that just says like check stuff, you don't know what you're checking, and it hides it too much. If you're going to do that, make sure that you like name it something that's meaningful. And I like to have all of my assert helpers start with assert. So like I could say assert 200 and correct title, for instance. You could do that. That'd be fine. But one of the reasons for parameterization isn't just to type less, it's to be focused on what's failing. So let's say in that case I had before, my test failed with the loop, and I could say, well, okay, so one page on my website isn't working. Which one? I have to go figure that out. I have to look at the error message. But if I had them iterated on the page name, I could go, oh, my contact one isn't returning. So there's something wrong with my contact page, and I know exactly where to go. So
Right.
Isolating the test failure is good.
Yeah. There was a comment before about if you have multiple asserts, you might not see all of the errors, all the details about that. And we talked a little bit about that too. And this helps show the status for the different parameters instead of I just loop through all the options and make sure they all pass or there's an error.
Yeah. And with like a website, for instance, there might be 2 pages. Whereas if you had them all in a loop, you'd only see the one. You're like, oh, contact page was broken. I'll go fix that. And you come back, oh, something else is broken. Whereas if it had like 3 failures, you'd be like, oh, like 7 of them are failing all of a sudden. Something else must be wrong.
Right.
But anyway.
Yeah. Related sort of on that same side, in my mind, this is like it taken to the maximum of parameterization is things like hypothesis, where you don't even tell what the parameters. You're like, vary some ideas and give it to the test. What do you think about this? Do you find this useful for you?
Well, it doesn't. I do. Hypothesis is an awesome tool. It doesn't really. It helps you think about a problem differently, because you have to think about like because you can't say like add. You can't test add by making sure that it returns 4, because it's only going to return 4 in particular cases. But you can say, maybe test a whole bunch of positive numbers, and I want to make sure that the result is positive. And so there's like these aspects of your system that you can test for. But the other thing that Pythopothesis is awesome at isn't actually testing the output. It's just making sure your code doesn't blow up. So throwing hypothesis at systems, I think the first awesome thing about it is just it tests some corner cases that your code might not handle right. So anything that throws an exception is going to get dealt with as, PyTest is going to fail because an exception's hit. So that helps.
Maybe not everyone is familiar with the hypothesis. Maybe just tell them like a little bit how it works and how it's like parameterization, but not exactly.
Well, hypothesis is just so you set up strategies and different things around, and they're decorators you put on top of your test. And then like, you've got an example of like, given a string that's text, and then you have S. So somehow, hypothesis will fill in the variables that you put there. Like normally if a test had a parameter, it would either be a parameterization or a fixture, but hypothesis utilizes that also and fills it in with hypothesis values. And so if you give it, if you say it's a string, it'll come up with a whole bunch of them, and it'll run your test a whole bunch of times based on, and I don't remember what the default is, but it's quite a few. It also checks the time. I think it doesn't make sure it doesn't like run for hours or something like that. But you can tell it how robust to do, and it just like makes up stuff. But the people behind Hypothesis actually are pretty good at coming up with some decent test cases that break a lot of kinds of software. So though that bit of that we think of as the old style that you think of as a test engineer of like coming up with wacky values, you don't need that anymore. You can just have Hypothesis come up with wacky values for you.
Right.
So
Think of strategies of like, well, these scenarios we should try to run through and just have it automatic.
but it's like things that you don't know that are constraints on your system. Like maybe your input system, give it Hypothesis tells you, guess what? It like breaks on all German names or something like that, or Unicode, and you're like, oh yeah, actually I don't. That's neat, but I don't actually expect it to ever get called with Unicode. So you can restrict the strategies and stuff. So, but how? So Jeff asks, I can't hear you.
Oh, sorry. Yeah, just maybe the last thing on Hypothesis here is, Jeff asks, how reproducible are tests with Hypothesis?
I don't know.
They do say that it remembers the failing examples, so into like a SQLite database or something. So maybe it'll replay that potentially, and I'll try the failing ones before, but I haven't played with that either. So
I think it reports like some seed thing or something that you can reseed it to be the same run or something like that.
Yeah, there's a whole section on reproducing failures here, and it does say you can provide, one of the things you can say is provide examples of, in addition to the random stuff you pick, please do these things. And so I suppose you could take a failing one and put it in there, or if you always do it with the same seed, then its randomness becomes deterministic. Yeah. Which is kind of odd, but
pseudo random is part of CS. Yes.
Yes, indeed.
All
right, well, Brian, we're pretty short on time. What else do you want to throw out there real quick before we?
I think I want to circle back to the beginning and just say PyTest can do a whole bunch of cool stuff. Don't do it all at once. Gradually add bells and whistles, especially if you're working on a team, because it's a different mindset. So it's make sure that the team is all up to speed. You want to make sure that, like all software, don't design a system so complex that you're not smart enough to debug it. So
I love thinking about that. That's a really good way to put it, because if you write the most clever code that you can, you're right at the limit of your ability to like keep it in your mind and understand it. And debugging code is harder than writing code. So
you're not qualified to debug your own code.
You're writing codes that you can't write code that your body can't pay the check for or whatever.
Yeah, I can't remember who said that first, but it's definitely very true.
It is indeed. Awesome. Yeah. Well, thank you for putting this together. Obviously, I'll link to this in the show notes. People can check out your course. They can check out your book. And it's all your other PyTest things. And we're looking forward to having Test and Code back.
And also, everybody that's listening here should be listening on Python Bytes. I think you'll enjoy it.
I agree. It's a lot of fun over there.
All right. Thanks a lot, Michael.
Yeah. Thank you for being here, Brian. Thank you, everyone, for listening. See y'all later.